Welcome back, everyone. Today we're going to be doing a little bit more in-depth analysis of a memory image that we might not know anything about, but we are going to use the tool Volatility, and I'll give a link to that tool. We'll use Volatility for doing a little bit more analysis. And Volatility is a very big framework. I'll move this over here in a second, which we can get information about. Basically, it's a community-built framework for doing a lot of different tasks in a lot of different versions of, for example, Windows and Linux and OS X. We can analyze memory in depth, much more than what we were talking about before, where we were just basically looking for keywords or extracting data structures. Volatility actually goes in and tries to reconstruct and parse out all of this data. So they have a lot of different functions, and it's a very large and very robust tool, and is one of the best memory analysis tools that are available. It also happens to be free, which is very good. So today we're going to be using Volatility, some basic functions of Volatility to do some basic analysis of this exercise1.raw image that we have. And I'm going to run Volatility. I have it installed in opt volatility vol.py. And this is where I have installed it on my Linux workstation. Volatility also works for Windows, OS X. This is just where I installed it on mine. So to first just look at what options are available, we can run Python and then this vol.py-h, and that should show me all of the different options that are installed that I can use. Okay, so these are a lot of different options that we can use here, and it gives me some information on how to run it. We have to specify, for example, profiles and things like that. So now we're going to go through and use some of these. So one of the first ones that I want to talk about is, where is it? Image info. Okay, so right now we don't know anything about this memory image, so we can use image info to try to get more information about this image. So we can do that by essentially running Python opt. Let me clear this out so you can actually see it. Python opt volatility, and then we need to give it the image that we have. So here, exercise1.raw. Okay, so here I have Python opt volatility vol, which is the location of my volatility Python script. -f tells me the file that I want to analyze, and then we can just run the module that we want. So here we say image info. Okay, so now it's trying to go through and figure out what it can about this image. Okay, so we can see a couple different things. The time that the image was created, the time and date, the local time and date, number of processors for this system, and some of the most important things, for example, is this suggested profiles, because we have to use a profile if we want to be able to analyze this system. So it's suggesting Windows 7 SP1, x64, Windows 2008, Windows 2008, Windows 7, Windows 2008. So we need to use one of these profiles. And what we are going to choose here is just, let's try the first profile. If you start to get errors or you're not getting all the information that you expect to be getting, then it might be because you chose the wrong profile here, but this should give us an idea. Let's just copy that and give us an idea of what's going on. So suggested profiles suggest where this memory image came from, which is why it's so important, if you can, to document what type of system your memory image is coming from. So whenever we were copying memory, whenever we were doing our memory acquisitions, we would name our memory image, for example, Windows 10 Pro x64 6 gigabytes or something like that. And that is for whenever we're doing more in-depth analysis and we need to know the data structures of, for example, process lists or whatever in the Windows system that we're looking at, and they change depending on the version of Windows. Okay, so now that we know or we have an idea of the suggested profile, let's say that we want to find all of the processes that were running in the system whenever this memory image was taken. So we can do, let's go back up. Instead of image info, I now know the profile, or I think I know the profile. So we can use profile and then equals, and then I had it pasted here, paste Windows 7 SP1 x64 in this case, and then we can run ps list, and this will give us all of the processes, the process list that was available in the system at the time. So let's run that, see what happens. Okay, so now we have all of these different processes that were running in the system with their PIDs, the times, and everything like that. So now we can see all of the different processes that were running, and basically all the information that we would kind of expect to be able to find in a system if it were on. Reconstructing this from memory, however, is quite difficult. So Volatility reconstructing this really helps us a lot. We can also look, for example, at the different network activity. So here, instead of ps list, we can use the command netscan. So here I have Python, vol.py, my file is exercise1.raw, my profile is -- profile Windows 7 SP1 x64, and I want to run netscan to look at current network connections that were active at the time. Okay, so now it's running through, and I can see all of the active, or basically established, closed, listening, all the different types of network connections that are available, and the process or the owner of this network connection. So then we can go through and see if there's anything suspicious here. We can see what websites the computer was connecting to. If there was a peer-to-peer network, what was that peer-to-peer network doing? If there's a virus or something like that, are there any network connections being established from the virus? So those types of things. Now we can filter this out. Notice this is a lot of data. So let's say that we are, let's say we're specifically interested in all of the network connections that are closed. So just like we did whenever we were doing basic keyword searching for memory, we can use grep and then vi and then closed. And what vi does is basically say we don't care about the uppercase or lowercase. So then we will filter out. Vi is filter out all of the closed connections. So we should just get listening and established connections from this. So we're saying I don't want to show closed, and I don't care about the capitals here. So all of this information should be removed. Okay. So one good thing about Volatility, well, there's a lot of good things, but one good thing is that we can pipe all of these commands into another command. For example, for filtering or for keyword searching, or maybe we want to look for a particular process. So we can do that quite easily. So now we have these established connections. And yeah, we can look at the different connections that are being made, the different ports, and the processes or the owner that is running these different connections. Okay, so now imagine that we want to try to detect some potentially malicious program. We would have to go through, for example, ps list and then maybe ps scan and some other commands and compare all of those manually to be able to see if a virus or some malware has been trying to hide its traces or remove itself from some of these lists. So Volatility has this quite nice tool called PSX View. And what this will do is go through and essentially compare all of these different, the output of all of these different commands and see whether something has been listed or not. So in PSX View here we have when a process was exited. So if we have, for example, so it shows the PID, the name, the offset, and if we have PS list, PS scan, thread proc, PS PCID, CS, RSS, and session, all of these different things. And what we find is if some of these are, for example, removed. If we have PS list, it's removed, but it's true in all. If it's false in PS list, but it's true in all of these others, well, this might be suspicious, actually. Just because why should it not show up in PS list, but show up everywhere else? We can still find it running in the system, but it's kind of removed it or detached itself from PS list. Now we look at some of these other ones. For example, down here we see false, true, false, false, false. Now some of these could just be have exited, or some of these just could have exited basically. And in these cases we have exit times. So to see true and a bunch of falses, maybe that could be a flag, but probably not so suspicious. The really suspicious one would be where you have where was it? You have a false, and then you have a bunch of trues. So in this case, it looks like this program, this process actually might be trying to hide itself. So we can use PSX view to try to get a comparison of all of these different essentially process information that volatility gives to figure out if something is a little bit suspicious and we need to dig into it a little bit more. Okay, so volatility has a lot of different options. We can't talk about all of them today, but it really depends on what you're trying to do. For example, TrueCrypt, passphrase, TrueCrypt summary. If somebody was using TrueCrypt, it will try to extract TrueCrypt keys from memory. Shellbags can print shellbag information, which you can use to prove that a user was accessing specific folders. Let's see if there's anything else here. Scan for registry hives, basically dump the hives, dumps passwords hashes from memory. If there are basically Windows password hashes in memory, it will dump those, and then you can try to crack them or break them, which might be useful for accessing other things, not only the computer. Dumping certifications, looking at trees, looking at different connections that have been made, looking at different command line arguments to processes, extract contents of Windows clipboard, which think about the things that you normally put in clipboard. It might be passwords, it might be credit card numbers, things like that. So volatility has a lot of different things. We just focused really on looking at process lists and connections here, but it does a lot more. So that is it for today. Thank you very much.